right, let me adjust this camera real quick. All right, that's better. Okay, so now we're on to Unit 5. Unit 5 is talking about properties of triangles. Okay, so that is their angle measures, that all triangles add up to 180. The exterior angle theorem, that is, your altitudes, your medians, angle bisector, perpendicular bisector, all that good stuff. There we go. That's better. Okay. So let's start with an easy one. So it says in triangle EFG, I don't know why it says E, and angle E is equal to 23 degrees. And angle F is equal to 57 degrees. Okay, so we want to find angle G. So I have 2 of the 3 angles. If I have 2 angles already, finding a third just means I'm subtracting from 180. Okay, so what I'm going to do is I'm going to go ahead and add angle F and angle E together first. So 23 plus 57. So that is 10. Carry the 1. 7. So I get 80. Okay, so I know together those 2 angles equal 80. And remember, all triangles the angles add, hold on, it's a little blurry. There we go. All their angles add to 180 degrees. Okay, so they always add up to 180 degrees no matter what. Okay, so I know that I can just subtract from 180. So 180 minus 80 gives me 100. That means that angle G has to be 100 degrees. Okay, so that one should be simple enough. All right, so this next one is a little more complicated because it's got x's in it, but you're not going to treat it any differently. Okay, so don't let the x's scare you. You would not do this problem any differently. We have all 3 angles here, which means I know that they should add up to 180 degrees because all my triangle angles are going to always add up to 180. So that's all exactly what I'm going to do. I'm going to say angle A plus angle B plus angle C is equal to 180. So angle A is 6x plus angle B is 3x minus 3 plus angle C, which is x plus 9. And that equals 180 degrees. Okay, so I'm going to combine like terms before I go across the equal sign. So I have a plus 6x here, a plus 3x here, and a plus x here. So 6x plus 3x is 5x plus another x is 6x. So I have 6x, and then I have a minus 3 and a plus 9. So that's going to be a plus 6. And that equals 180. Okay, and now I'm going to move things across. I'm going to subtract this 6 from both sides to move it over here. So that gives me 6x equals 180 minus 6. I'm going to borrow, so 7. 10 minus 6 is 4. Bring down the 7, and then bring down the 1. So I get 6x equals 174. I'm going to divide by 6. So x equals, I believe, 29. Let me just double check real quick. 174 divided by 6 is 29. Okay, so x is 29. So just like when we were doing with the angle relationships, if it asks you for an actual angle measure, all you would need to do is then take x and plug it back into my angle. So like angle C is x plus 9. So if I put in x, which is 29, plus 9, that means angle C is going to be 38 degrees. Okay, it didn't ask for that one, but just in case it does, I wanted to give you an example. Okay, all right, so this next one Specifically, it's talking about exterior angles. Oh, it says, what is the value of x? Well, we're also going to find what the value of d is. It is the value of d, because we want to talk about those exterior angles. So the first thing I should know is angle x, right? I have it inside the triangle. So I know that these three angles together inside the triangle should add up to 180. So I'm going to go ahead and do 51 plus 42. So that is 3, that's 9. So that's 93. And then I'm going to subtract from 180 because they should all add up to 180. 93. I'm going to borrow. So that's 7. 10 minus 3 is 7. Got to borrow again. 17 minus 9 is 8. So x equals 87 degrees. So this is 87 degrees in here. Okay. Now, there are two ways we could find d. The first one is I could say that together 42 and d make 180 degrees because they make a straight line together. Okay, so I know that 42 plus angle d equals 180. But I would also know that whatever these two angles are, these are called my remote interior angles. My remote interior angles, if I add them together, that will also equal d, because these added together and subtracted from 180 equal 42, and we said that 42 plus d equals 180 as well. Okay, so there's two ways you could do this. So I'm going to do this both ways. So 51 plus 87, that should equal angle d. So 51 plus 87, that is 8. And then 13. So 138 is angle d. So we can double check that. So I'm going to subtract 42 from 180. So angle d would equal, so we got borrow, 7. 10 minus 2 is 8. 7 minus 4 is 3. And then bring down the 1. 138 degrees. All right, so either way, you still get the same answer. Oh, can you not see that? You still get the same answer no matter what. One's just maybe a little easier for you to understand, so you can always pick that way instead, okay? All right, so now we get into our special segments of triangles, okay? So my first one, we call this an altitude. Okay, so an altitude is always going to start at the vertex. Okay, so my line got to start at the vertex. It's going to go straight down, and it's going to make a 90-degree angle. Okay, so my altitude makes 90-degree angle. Okay, so a problem might ask you to solve for, it'll tell you that this angle is 3x plus 5 or something, and it says that this line is an altitude. Then you can know already that this angle should be 90 degrees. And if it should be 90 degrees and it's also 5x plus 5, whatever, you set them equal. So I say 5x plus 5 is equal to 90. Okay, this next one is called a median. Median. Okay, we again start at the vertex. So median is going from the vertex and it's going all the way across my triangle to the midpoint. Okay, so remember a midpoint is the point in the middle. Okay, which means that this segment from here to here is the same as this segment from here to here. Okay, so a median cuts a side in half, or bisects. Okay, so it's going to cut that side in half. So I know that this segment should equal this segment. All right, so the next one, here I'm going to underline these. Okay, so the next one is an angle bisector. Okay, it's exactly what it sounds like. It bisects the angle. So this one as well starts at my vertex, and then it's going to bisect this angle at the top. So it's going to cut the vertex angle. So wherever we start with my angle bisector, that's the angle it's cutting in half. So cuts vertex angle in half. right? That's bisect. All right, so wherever my vertex is that we start at, that's the angle I'm cutting in half. So if I started at this vertex here with an angle bisector, it'd be cutting this angle in half. Same thing over here, it'd be cutting this angle in half. So that means that if I cut this angle in half, this angle right here is going to be equal to this angle right here. They'll make the exact same measure. And then the last one is called a perpendicular bisector. Okay, so perpendicular bisector is special because look where it starts. It doesn't start at the vertex. Doesn't start at vertex. Okay, so the reason why that is because we want to bisect a side while also having a 90-degree angle. Okay, so that means I'm going from the midpoint and I'm just going straight up through my triangle. Okay, so I get a 90-degree angle and I get the side bisected. Sected or cut in half. Okay, so those are my 4 special segments. All right, so keep those in mind. We're going to do a problem on median in just a second, okay? But you need to make sure you can identify them. So if I were to show you, oops, okay. There's the rest of perpendicular bisector, sorry about that. So if I were to show you this picture, you need to be able to identify that is a median, and I need to know what medians do. They cut a side in half, okay? Same thing with any of these, okay? So if I show you a picture of an altitude, you need to tell me it's an altitude, and you need to tell me why it's an altitude. Angle bisector, you need to tell me, is that an angle bisector? It is. Why do I know it's an angle bisector? What is it doing to my triangle? Okay, it's bisecting this angle at the vertex. Again, this test is going to be multiple choice, so you can always use process of elimination, but make sure you know what the pictures look like and what they are doing, okay? All right, so this next one kind of goes into isosceles triangles and kind of goes into our triangle angles. So isosceles triangle, in case y'all forgot, isosceles, that just means that 2 sides are the same length. Okay, so I can tell this is an isosceles triangle because this length, this little tick mark, is the same as this length. So remember that the little tick marks, that means that we have their congruent sides, okay? So it says I want to find the measure of angle 1. So angle 1 is right here, okay? So I know this angle is 100 degrees. What else I know, because this is a isosceles triangle, not only are these sides congruent, but these angles, my base angles, the ones that are across from my congruent sides, they are also congruent, okay? So I know that angle 2 equals angle 1. And I also know that that angle is 100 degrees. And I also know that 100 degrees plus angle 1 plus angle 2 should equal 180 degrees because it's a triangle. So if angle 1 and angle 2 are the same measure, I can go ahead and call this x, so let's call these x. Okay, so let's say 100 plus 2x, right, because this is x and this is x because they are the same, equals 180 degrees. So I can go ahead and subtract 100 from 180. So it gives me 2x equals 80. And then I'm going to divide by 2, so 2x equals 80 divided by 2. So x would equal 40, okay? Now you could also look at this and say, I know that these are the same, so I know that whatever 180 minus 100 is, divide that by 2. That would also give me my answer, so that would be 180 minus 100 is 80, and that over 2 is 40 as well. Okay, so either way, you don't have to use variables. If you can just understand that, that's fine. Okay, so my x would equal 40 degrees, which means also angle 1 would equal 40 degrees. Okay? All right, so this next one. First of all, we are going to identify that. So we have the pictures right above, so you should be able to identify what that is. That is a median. Okay, so I'm going to go ahead and write this is a median. And what do medians do? They bisect sides. They cut my sides in half because that is the middle. So this side, AB, or that's AD. AD equals my other side, DB. So I know that those two equal each other because that is a median. So it says if angle CDA is 30 degrees, so CDA, that is 130 degrees. And angle B is 70 degrees. What is the measure of angle BCD? So we want BCD. So we want to find this one. This is X. Okay. Well, funny thing is, this problem didn't even care about my sides. So the fact that it's a median doesn't really mean much to us, but that's okay. I know that together, this angle, my 130, and this angle right here, my missing angle for my triangle, they should equal 180 because they make a straight line. So if I go 180, so let's call this angle 1. So I know that if I do angle 1 plus 130 equals 180 because they make a straight line. So I'm just going to subtract 130. So angle 1 would equal, see the 0, and that would be 5, and that would be 0. So we have 50 degrees. So angle 1 is 50 degrees. Now we're not done. We're not actually looking for angle 1. We just need it to solve for x. Okay, so this is 50 degrees. So I have the 50 degrees, I have the 70 degrees, and now all I'm missing is that top angle. So I know that 50 plus 70 plus my angle that I'm looking for, BCD, should equal 180 degrees. So I'm going to go ahead and add these two together. So 70 plus 50, that's 120 degrees, plus angle BCD equals 180. And now I'm going to subtract 180 to both sides. So that is angle BCD, and that equals, so we got 0, 8 minus 2 is 6, and then we have 0 again. So angle BCD equals 60 degrees. Okay? So while we need to make sure we can know what these things are, we also don't want to forget our things we already know about triangles, right? I already know that those triangles should add up to 180 degrees, so that will be always true. All right, so last one for Unit 5. All right, so it says AC, if AC, so AC is this long one right here, that is 28, and it says AB is equal to 30, so AB, it's right there, and FD, so FD is just this little one right here, that is 12. What is the perimeter of each triangle? So remember, perimeter is sum of all the sides. So it looks like we got to find two perimeters. We got to find the perimeter of the big triangle and the small triangle. So first thing I want to talk about is a midsegment. So a midsegment are what these inside lines are, what they're making that triangle out of. Midsegment. Okay, so a midsegment connects the midpoints of two sides of a triangle. Okay, so this, what letter is this? That's F. That's F, E, D. I'm gonna write them a little bigger so you can see A, B, C. So that means that FE is a midsegment, FD is a midsegment, and ED, those are all midsegments, okay? They are connecting the midpoint of all those sides, okay? So something interesting about midsegments is, first, those lines are parallel. So it's parallel to its corresponding side. So FE would be parallel to AB. They would be the same, have the same slope, okay? And then also they are 1/2 of the length of its parallel side. So if I said FE and AB are parallel, then I know FE is equal to 1/2 of its corresponding side. In this case is AB. Okay, so I know midsegments are 1/2 of their parallel sides length. So I know FE is 1/2 of AB. I know that FD is 1/2 of CB. And I know ED is 1/2 of AC. So if FE, we do not have FE, we want to find FE because I need to find the perimeter. Okay, so I know AB is 30, so 1/2 of 30 would give me 15. So I know that FE is 15. So FE is 15. And then I know that FD is 1/2 of CB. So I don't actually have CB, right? I have FD though. So if I want to find CB, then I'm just going to move this 1/2 to the other side, right? So I can either divide by 2 or I can multiply it by its reciprocal. So times 1/2. So that means that 2 FDs equals CB. So FD is 12. So 2 times 12 is equal to 24. So CB is 24. So this whole thing is 24. Okay, and then my last one, ED is 1/2 of AC. So AC is 28. So ED equals 1/2 times 28. And that is going to equal 14. So ED is 14. Okay, so now I have all their side lengths. Now I can solve for the perimeter. So all I'm going to do is add all the sides together. So for triangle ACB, add 28 plus 24 plus 30. So 28 plus 24 plus 30 is 82. And then for triangle FED, it's going to be 15 plus 14 plus 12. 15 plus 14 plus 12, which is 41. So, do you notice anything funny about those perimeters? Notice that the big triangle is double the size, double the perimeter of my small triangle. Okay, so if you found the perimeter of 1, we actually only have to then multiply by 2. Oops, wrong direction. This way. So if you find the small triangle perimeter, you only have to multiply by 2 to get the big triangle. And if you want to go this direction, we would multiply it by 1/2. Okay? So either way, you can find each perimeter separately. But if you want to just find one, you can either double it or 1/2 it, depending on which triangle you found. Okay? So that is the end of Unit 5. One more unit to go.